Hang on. Yeah, no, nothing, mate. That is ice, mate. This is external to the building. It's got no connection to earth. Under fault conditions, the potential of this would rise. So this is basically a big switch. Below here is a CT chamber. There'll be some pads and some bus bar. 1, 2. It's clear. What's good, guys? Welcome back to the channel. So today I'm back on that massive project and we're actually validating some external lighting. This is a complete refurb of the whole building, all new external lighting as well. However, a lot of the positions of the existing lighting suit the positions or where the new lights are going to go. So what I've been tasked with today, with my big drawing down here, which I'll run through, going through all the existing circuitry, doing R1, R2 testing, insulation resistance testing if I can, validating and making sure that's all okay so it can be rejigged and reused. We could do some live testing, but to be honest with you, all of the mains characteristics, the boards, the incoming, everything is changing. So what we're going to do is we're going to get all the dead test results and then they'll design the new breakers and the new switchgear to suit these circuits based on that. So it should be quite an interesting one, lots of testing, lots of looking at outside lights. It's about -2 today, it's absolutely freezing. Hoping it gets a little bit warmer, but if not, we'll be out in the cold having fun. This is my drawing, so I've done a bit of highlighting, different circuits and what have you. We've got about 5 lighting circuits, and then we've also got like, barriers, switch room or substation supply, another barrier there, all sorts to test. I'll take you through all of that. I've got my trusty test kit, my KT66DL. I've got Jude as well, he's gonna be on the camera. So yeah, we'll run the intro, we'll get into this video. So this is the board that's not the right screw. This is the board that all of the outside lighting is fed from. There's also been some other stuff just dumped into here because it's the last LV board basically. This is all coming out, as is the panel behind me, and all new will go in. So what I want to do is basically isolate all the circuits I'm going to work on, link them all out so I can do R1, R2 testing. It's always a nice kit, this ABB stuff. Got the exposed links there, it's pretty smart. Perspex and that, you don't really see too much stuff like that, on 3-phase boards nowadays. They're relatively simple. Quite a safe board as well. Obviously we're missing a neutral cover there, but we've got tags on all the phases. Pretty safe to work in. I want to start with, we could work methodically actually, bollards entrance, 1R. Let's turn that off. So these are just links up to the contactors, which is interesting. What they've done is they've sent the actual neutrals and earths to the board, but the lives obviously going to the top of the contactors. So this is basically a contactor setup. I believe this switch has been thrown in to give us some sort of control. All of these circuits come on in tandem, they all come on at the same time, and that's what this timer and this switch does. All of the circuits are permanently fed essentially from the breaker to the end of lines, but then you drop these switches just after them as soon as they leave the board, and all of these contactors, these relays, are controlled by one circuit, and that's how you use a little load like a timer probably on a, a 3 amp breaker to control what we got there, 6, 8 outside lighting circuits, all on 6 amp, 16 amp breakers. That's how you can literally use a tiny little load to control loads of larger loads. It's very common with outside lighting, it's very common with emergency lighting, last man out switches, stuff like that, and of course any sort of building management system or motor control centres, stuff like that, albeit at a far bigger scale. What this means for me though is I'm going to have to kill all these breakers. That can go off, 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 barrier, that can go off, car park barrier, that can go off. That can go off, that's cameras. 6B is the intake room lighting and power. That can go off. And then what have we got? We've got 7R, which is ECS controls and time switch. So that is the breaker that feeds these. So I've got everything out of the breakers. I've got 1L1 connected to earth. Everything else is disconnected. That's basically going to be my form of isolation, removing of fuses. And then we've got a locked room. I'm going to put the cover back on, and of course we'll be proving for dead at the other end. One thing I've had to make sure to do as well is make sure this little switch is on, and of course this circuit is energised so that all of these contactors are letting through. If they weren't, basically these circuits, or the lives of these circuits anyway, would run out of this board and they would stop here. They wouldn't go any further, obviously not allowing me to get a R1, R2. So by having the contactors energised, these are of course going to let through and allow me to get the result at the end of the circuit. So when you're testing more complex installations with contactors and stuff, you just want to make sure you're doing stuff like that, because otherwise you'll just be scratching your head a lot. I've taped up all the cables that I've removed, and yeah, we'll go test 1L1. Obviously this is going to be an ongoing thing, cover on, cover off, link out, but that's all part of the fun. I was just saying how nice this board was, but whoever done these blanks looks like they use their teeth. Right, we can then get that on. My key for this door is in my tool bag, so I'm gonna do one of my very own pet hates. There we go. That's locked. I'm gonna lock the room. We'll head upstairs and start testing 1L1. Right, so just get this fired up. We want to jump onto continuity. Just put this on auto test. Press that. Let's put no on. It's going to send that down to 0. Our leads are now nulled. I should be able to test again. And they're 0. Cool. Bang onto auto test. I'm going to go between these two, and I've got 1 point. There we go. 0.46. I was going to say that was way too high for the size of these 6mm. 0.46. These are made off atrociously. The steel wirings aren't even in. That's essentially an R1, R2 test. So live or R1 linked together with earth, or R2 at the board. And then obviously this wasn't end of line, but we just want to test at the end of line, and that'll give us our R1, R2. If you add that value together with your ZE of the board that supplies this, that will give you your ZS. You can also test for your ZS, and that's the magic number that we want to make sure is below the prescribed value of the breaker to make sure the breaker trips on time. It's quite an important test. For the guys today though, to be honest, it's just so that they can design and also ensure that these circuits are okay, basically. How is that a different size? What are the chances in that? So this one isn't end of line. It's also been bodged together. Don't need to test here, but while we're here, why not? 0.47, a little bit higher as we'd expect. Again, like, they are made off atrociously. The arm rings are just sort of taped together with a bit of electrical tape. Yeah, no glands, and then these are just lashed in. Get this tucked away. That's obviously come off of there. Again, these are not going to get energised again, so I'm not too worried about how they go back. This screwdriver is amazing. We actually don't sell it anymore on load out because I think it's discontinued. But yeah, you get a couple blades. I think I've got like 4 blades. But yeah, it's great for testing because you've got a PH admittedly, not a PZ, and a flathead on one, and then the other one's a PH1. This is a PH2, the other one's a PH1 and like a 3.5. So yeah, it's just a great little testing screwdriver. Pops out. Yeah, Klein as well. It's nice. They do a full set, but this one was like 20 quid, so it was like a no-brainer. But you can't get them anymore. I'll have to look into it, to be fair, when I'm next back in the warehouse, see what's going on. But yeah, discontinued as far as I'm aware. So this is going to be 3 for 3. This will probably be our highest value. Yeah, it was just luck of the draw really, out of these 3 lights. It ended up being the last one, but there should just be one cable here. Yeah, and there's only one cable coming in, which means that was never a light, you would think anyway. So I'll just have to annotate on the validations on the drawing that they are going to have to get these blocks up if they want another bollard there. And then let's go between neutral and earth, live and earth, sorry. Just make sure these are all in. We've got no continuity. (1L1). Is there any other 1L1s? Hello mate, you alright? Yeah, good. Got a result, 2 cables.
Yeah.
Got a result, 2 cables. No result, 1 cable. You'd think that's end of line though, wouldn't you? Right. But I've tested between neutral and earth, and there's no continuity there, which if it was connected at the mains...
What we do have,
I've just noticed that as well. Is that a fucking uplight, or is that a... Oh no, I thought that was dirty glass, but...
What you have down there is one which is marked up, on the front of the board it's marked up entrance socket, but on the board chart it's marked up future lighting.
Ah, okay.
Do you want me to show you where that is? It is down there.
Yes, mate.
I'll show you.
Yeah, we're all alright here, aren't we? Yeah. You crack on, boys. You won't be in it, don't worry. It's all blurred out. It's all blurred out. It's the benefit of fast glass, isn't it? Does all the blurring for you. Hello, mate.
Alright, mate. What colour do you want to go between?
Red and yellow, please, mate.
No, nothing?
No, mate. Nothing. Hang on. Yeah, no, nothing, mate.
No, it looks like it looks pretty much like to me like this is actually a pre-phase cable.
What is it? Is it like a 6mm SWA, yeah?
Yeah, it is, mate, yeah.
Okay.
Anyway, alright.
No worries. Cheers, mate. Bye. Bollard's entrance 0.48. Okay. It is 6mm. So check this out. We're all familiar with Wagos now. It's 2022. Obviously, you pop the sides, you lift the box up. It's resealable. It's a lovely box. One of my favourite things about Wagos, it's not only the Wagos, but the nice, easy box they come in. Callum, from last week's video, the new guy, opens them like this. But this side's still not even off of the tab. Who opens a box of Wagos like this? Never trust a man who opens a box of Wagos like that. That's why he's not here this week. Refused to work with him. These are so new to my testing arsenal that I'm literally, like, they're not even part of my workflow. I always forget. I always forget about them. They're the leads from Q-Tech, the little crocodile leads. And yeah, I've had them in my test kit for a while. And I constantly forget about them. Obviously Wago's great, but these are 2 different size cables, so it's causing me drama. What I am going to have to do though is just lock this room, because I'm not going to be able to get the board coming back on. So yeah, we'll just be relying on the locked door, but yeah, it's alright. Right, let's go and start taking apart these lights and see where we get. I'm going to try not bore you with the same thing over and over again. I appreciate that, but the first one was a bit hit and miss. But we'll do this one together, and then I'll probably just show you some IR testing, any crazy shit we find. We'll go from there. Let's lock this door from the inside, and we'll lock the other one from the outside. Where are we? We're on the back here. We're at this light here. This runs all the way down to there. There's a lamppost there. Apparently there's not one there. So you'd expect this to be our first point, and I just want to check that. Basically, I just want to get the result here and see if it rises, and also just have a little look at what the incoming position's like. Now, thanks to someone in the last video on commercial lighting, they made me aware when I didn't have a key that these can be undone with a 10mm socket, which they can. What a legend. So yeah, I can't remember your name, mate, but that is a great shout. In here we've got the fuses, and we've got one cable here, which is interesting. So that means this is the end alignment. I mean, it's the closest one to the car park and the switch room, but cabling wise maybe it was easier to go out that way to that one. But yeah, that is why you do check, because sometimes you get lucky. We should be able to test from here too. There we go. Yeah, little 6 amp fuse in there. Both covers off. I'm going to go between you two. 1.48, which at the end of quite a long circuit isn't too bad, to be honest with you. Isn't too bad at all. This is on external lighting. It's on a C16. The maximum ZS recorded at the time is 1.2 though, and that is a clear 1.4. So the boys potentially look at dropping the breaker size, but I don't think they'll get away with that. I mean, if they're going all LED, that's quite a possibility. Might be able to drop down to a 10 amp, which obviously give you a higher tolerance. But yeah, at the minute that's not fluctuating, that's sitting bang on 1.4. So yeah, that would have failed me old mucker, but obviously it's all coming out now anyway. But yeah, that's what again, it's quite important with validations. Sometimes circuitry's just staying regardless. So obviously this circuitry's staying, but it's, you know, the mains is being overhauled, everything's being overhauled, everything's being changed, new lamp posts. They're just reusing that cable, literally just reusing that out of convenience. It still might need to be jointed or whatever, just to save on groundwork and stuff like that. But you know, in a lot of cases, you might renovate a building, but a whole floor stays as is, and the main stays as is and everything. So validating the results against the existing switchgear is very important. Obviously validating all the internals of this, the condition of it's very important. I've done painful validations where we're basically taking responsibility of an older install, and the price of the job, you know, could be £1 million job, is based off of this existing kit not having to be renewed, not having to be altered. So validations are very important, and there's actually, to be honest, not a lot of guidance on them. Obviously this is, you know, testing. I know how to test, I know how to do an EICR, I know how to do an initial verification, but validations are, you know, you're sort of validating what you need to validate. So it could be a lot of work, a little bit of work. They're always tough. I actually done them quite a bit when I was full-time at Burgess, but yeah, an example there of why it is important. you want to check that as well, because I don't know who filled out that certificate. They could be completely wrong, you know, on the maximum ZS for that breaker. Who knows? They are also 3871s, so they're an older breaker to an older BS number. Obviously, yeah, your traditional breaker, 60898 or RCBO, will be maybe more tolerable as well. Might be a better device in that respect. So yeah, we've got to look into that too. But at the minute, like existing install wise, that fails, which is yeah, interesting. So there's not one there. Let's go have a look. Let's shut this. I'm going to need you. I'm going to need a screwdriver. We'll leave this here because we'll head back this way. Did you get it? Where is he? 4K, mate. Caught in 4K. Right. This one I think's on a different circuit because again, there's one cable here. It's end of line. Oh no, because I shouldn't have continuity between live and earth. But what's mad about this one is it's obviously full up with water, and look, it's frozen. That is ice, mate. So there's that much water in that column, and it's frozen, which is mad. I've seen them with a bit of water in, to be fair, but I've never seen them like that. Okay, so that's dead. We're on auto test, and yeah, we've got no continuity on that one. So that is going to be part of a different circuit, which means that's probably the end of line of this one. I just need to mark that up on the drawing because it's very deceiving. There's a new entrance going here, and there's lampposts either side of it, and this looks like it could serve that, but obviously it can't because it is on the other side. Sorry, Spider, I've woken you up, haven't I? So that one he's crossed off, to be fair, and that one is there, which makes sense. Someone's hit this one. Oh mate, I can't get enough of this hack. Do you know how many times I've been without a key and I could have just been using a 10mm socket? Okay. This one's full up of water as well. A lot lower, but yeah, full up. Right. And woodlouse. Go. So this one we should expect to get a result on. Jump on auto test. We're not getting anything. There we go, 0.76. So it's lovely and low down this end, but the other end, it's not compliant. 1.46, so I've got a note of that. That is this one done. This is the first point, so I'm also going to mark the end of lines on the drawing for them, because again that just makes their lives easier, makes the boys in the office lives easier anyway. And yeah, that was all right this end, and then it doubles by the end of it. So yeah, I mean it could be some poor connections that are adding to that effect, because it is, you know, half the value here, considerably lower anyway, but who knows, to be honest. Don't pass at the other end. That's that one done. While we're here, what we want to do is we want to tick this one, we want to put on this one and
of line, EOL. And we want to put this one first point. Now we can move on to the next one, via the main tube. I'm probably not going to show you too much of this next view, because it's basically the same thing over again, linking out at the board, go in, finding the end line, finding the first point. So we'll probably crash out a load of them. Obviously, if we find anything interesting on the way, I'll catch up with you, and then I'll show you a bit of insulation resistance testing. But yeah, for now, I'll catch you in a bit. Right, so this one's just been tested, 0.40, decent reading. But I didn't get that reading straight away. I was scratching my head a little bit, went back down to the board. I'd just gone from the live, used a crop clip onto the earth bar, got no continuity. Rummaged around the board a bit. The earth for this circuit has been tucked away, disconnected in the back of the board. Now you've seen from that lovely B-roll sequence we've done, this is all full of water, damp. So that means someone's disconnected the earth because it was tripping to keep this rolling. But this is an outside bit of kit. This is external to the building. It's got no connection to earth. Under fault conditions, the potential of this would rise. Yeah, that is incredibly dangerous and a mad find. Obviously, none of it's going to get switched back on until we can get that earth connected back in and the circuit staying on. But yeah, it's just mad what you find when you're testing. Mad what you find. I'm going to get this one buttoned up, do a couple more lamppost circuits without you guys because it's getting a bit samey, and then I'll catch up with you in the switch room. So I'm in the sub, the LV side of the sub. I can show you something a little bit interesting. So this is basically a big switch. Below here is a CT chamber. There'll be some pads and some bus bar, and then yeah, there'll be a cable coming in from the UKPN switch room, there'll be a transformer in there humming away. There'll be some switches. Comes into here, gets CT'd, sent to these 2 meters. Don't know why there's 2. But yeah, anyway, 2 meters, that cable goes back into there, and that cable also gets sent all the way back to the switch room too, so I guess it can be monitored in there. And then yeah, this is just a big ACB, so this is actually 1250 amps as well, so it's actually the same size as the one back in the switch room down in the basement. But we're not going to be messing with any of this. At some point I will be pulling this switch to strip out that panel downstairs, but today we're just looking at it. I'm testing this tiny little thing down here, which is far less exciting, but it's the last circuit we need to do. There is 2 more circuits which are brick lights, and they're fed from the car park underneath the building, and then they run around the perimeter, but they're basically, I think the lights themselves are staying because they're in the brickwork, and then we'll just pull a new feed to them. So we just want to validate, yeah, what's left. Again, I won't show you that because it's just more of the same testing, so it's pretty boring. But what I will show is me trying to attempt, and most probably fail, IR test on these circuits. I just really don't have good expectations for it. I think we might be better off doing insulation resistance once most of the columns are stripped out and the lighting's stripped out, because basically they're all in the ground, it's all wet, it's all been made off terribly, and I just generally think you're not going to get a good reading. But we'll see how far we get. This is incredibly tight. They've made this off and nicked all the slack elsewhere for sure. But we'll put that on there, 0.28, which is lovely and low to be honest, considering this is quite far away. 0.28. And that's that done. Like I say, 2 more circuits to do, and then it's just insulation resistance, and I've just made some notes basically on stuff that doesn't make sense or where it got mapped out before, just judging on, you know, what lights come on basically of the contactors and stuff. Some of the circuit references are a little bit wrong and stuff, so get all that wrapped up and that will be it. So we've got the power off back in the basement, and we're going to be doing some insulation resistance testing. Now, I've just spoke to the guys in the office. Personally, I don't think we're gonna get a decent reading, just because everything's damp, everything's made off terribly, everything's connected. Of course, during validations when it's all going to get stripped out, we don't really want to get too involved with that. But I'm going to do it anyway, and what I've advised is, like on initial verification, we do it at multiple stages after this. When all the existing kit's been removed, we've just got cables, do it then, and then when the new stuff starts getting fitted as well, do it then. For now, just to prove the cabling, I've isolated the board, I've disconnected the earth and wedged my mirror between it, because it's got a bit of pressure on it. It would touch the casing and basically give continuity still. So I've wedged that in there. I'm going to bang this on here. I'm just going to run through basically one by one. Not doing live to live because all the loads are connected, but live to earth, and see what we get. Nothing there. Of course, the contactors. 0.05J. 0.5. Don't worry about putting 1R because we know that from there, basically. So just put it next to it. Do a slash and then write whatever result I tell you. Hang on. R2 is clear. So just put greater than, just put clear. Y2, which should just be below it, 2Y, it's clear. B2 or 2B is 0.012. Put a large M after all of them as well, mate.
What, even on the clear ones?
Not on the clear ones, sorry, yeah, just on the results, mate. Okay, Y3 is clear. B3 is 0.12, 0.012, so really low. 6Y is a dead short.
What should we put DS for that?
Just put 0.00, yeah. 6 blue, B6 is a dead short. So make sure that's not touching, which it isn't. Cool, and then the only other one is R3, and that is 2.4 megaohms, 2.4. So that one will actually pass. Got a couple of clears and a couple of fails. Now, of course, you saw it, it's all full of water, really badly made off, it's been neglected. What we're expecting though is once we actually dismantle that existing kit, start putting all the new stuff in, these readings should really clear up. But for now, that will have to do. We're going to get these last 2 circuits in the car park done, and we'll probably outro the video then. Right, so that is all for today, guys. I've just checked the last 2 circuits. Basically, they're getting a new feed put into them, but what we want to make sure of is that after that feed, you know, all the daisy chain lights, all the lights in series are okay, and they are. So that is it. Hopefully you found it interesting. Obviously, real world validations, making sure everything is fit to be reused, repurposed, whatever. Not an exciting, particularly video, but hopefully you've seen a bit of testing, you've seen how I do things, the kit I use. Yeah, I've enjoyed making this one. That's important, and hopefully you've enjoyed watching it. Make sure you check out Loadout for all the tools and bits and bobs you see me use throughout the day. Thanks for watching again. I'll catch you on the next one.